It's an open source project. I don't think so. Okay. Thank you very much. We're now starting with GPG for email.
Or PGP. Okay. So, apologies in advance for the haphazardness. This is a diagram I drew of email architecture. Quick show of hands. Who uses email? Right. Who uses webmail in the web browser? And who uses a desktop mail program? Right. Okay. Sorry?
Depends where.
Yeah, sure. That's correct. They're not mutually exclusive. It's okay. This talk is targeted towards the desktop email app sort of thing, though. Basically because it gets rid of one of the attack vectors. So, why have I got that slide up? Let's start with slide number 1. Okay, so we have Alice and Bob, and they have separate email service providers. I haven't named the providers, unfortunately. So Alice is with hers, Bob is with his. The attackers, the malicious parties, they're all in red, and their names all start with M.
Okay.
Missing Mallory.
I'm missing Mallory. Yes, that's because they're all Mallory. Okay, so I haven't included some attack vectors that you can come up with. For example, anyone on Alice or Bob's own machine, looking over their shoulder, stuff like that. So these are the ones that PGP actually helps to defend against. So that's anybody between Alice's machine and Bob's machine. So one thing to note is that email is actually stored at the mail provider when it's at rest. So when Alice sends an email to Bob, it goes to Bob's mail provider and stays there. Bob can go and read it from there, but generally the email just stays there. Same the other way around. We have a webmail edition of the same thing, except this time the webmail client, what was running on Alice and Bob's own desktop, is now running is now run by the mail service providers. Okay. I haven't quite figured out how to work this in, but basically when you're using webmail, it's the email client program, which in this case is at the mail service provider, that needs access to the keys. I haven't explained that yet. To actually do the encryption signing. Also, I haven't explained that. Okay. So, PGP can be used for encryption, communicating privately, and signing, which is making sure that your message, well, firstly is who it says it's from and hasn't been tampered with. So I'm fairly sure there was another slide. I mixed them up somehow. It's a bunch of acronyms. I don't really want to go into them.
Oh.
Sorry?
Go back just for a second.
Yeah.
Okay.
So these are just parts of the email system, and as a user, we're not really concerned with these. We just care about whether our message can be picked up and looked at or not. Okay, so The way PGP works is you generate two keys. They're related, a public key and a private key. Public key can be used to encrypt an email to someone, so only they can read it, or it can be used to verify things that are signed by them. The public key is public. You give it to everyone. Private key is kept by yourself. You don't share it with anyone. And it can be used to decrypt emails that are sent to you using PGP, and can be used to sign emails that you send. So in this case, Bob is distributing his public key, which is a silver one, to everyone. There's a couple of ways you can do this. My favorite way is to email it to them. But you can also upload it to a key server and ask anyone who wants to email you something using PGP to go and download the key from the emails from the key server.
Is it text or binary?
PGP,
The key.
it's a key.
No, but is it? I know of them, but I've never seen them. Are they binary or are they just ASCII?
Like as in what their representation is when
Well,
you're
for instance,
handling them.
Well, that was my first question. If it's just ASCII, can you just put it on a website?
Yes, you can.
Okay, so it must be ASCII rather than binary.
Well, you can represent it both ways
Okay.
It's an ASCII representation in BitHead.
in base 64.
Okay.
Yeah, so you can handle it both ways, but
Okay.
yeah, ASCII is quite convenient.
Okay.
So we're up to example of Alice encrypting an email to Bob. So Alice has to get Bob's public key, which you got before, uses that to encrypt the message, sends it to Bob, and Bob uses his private key to read it. This is Bob signing a message for Alice, and Alice verifying that Bob is the one who actually sent it. Okay, so this is the fun part, and what I wanted to get into is actually just a walkthrough of all of this. So I've gone ahead and actually not. Right.
Can I ask another question?
Yeah.
If you need to keep your private key private, and you have, as an example, I keep my computer connected to the internet through an Ethernet cable through a modem.
Yeah.
Would it be wise to not have that private key sitting on the computer and actually just have it on a memory stick and only attach it when you're using it and then take it off?
You could use it that way. The private keys are protected by a password, though. Yeah.
Okay, so you could sit there, but couldn't somebody crack it?
If they can crack a password, yes.
Okay, so there is a certain
It's a trade-off.
greater degree of safety by just having it on a stick. Okay,
Yeah, but then you can lose the stick.
that's true. Less likely to lose the stick than somebody coming on my computer, especially if you keep it at the computer.
Unless you're big.
Put it on a smart card.
I can't comment on that. I have no experience with smart cards.
They can put it on a smart card. It never leaves the private key never leaves the card. You get.
Isn't there there's a product like that on what's it called?
Chip Whisperer.
There's a key, like a little USB key that has encrypted systems, especially for having SSH keys and things like that on. So
Is there a manual from?
YubiKey keys or something like that.
okay, that's the one I'm thinking of. Yeah.
There are lots of them. Lots and lots.
It's a bit like your house keys. You want to have a few copies around, but you don't want to have too many around. You know, you want to have a couple of spares, but you don't want to have 1,000 old copies around that you can lose. You don't know where they are.
Oh, it's coming up behind the presentation. So this is going to be fun. Okay, so the walkthrough is going to be using Thunderbird. It's basically the one I use and the only one I really know. I've heard that Evolution has some support. I have no idea what it's up to. I'm basically going to be following the walk or the tutorial at emailselfdefense.fsf.org. So if you want to actually remember something from this, just write that down. So once I find my email client, I can actually go for it. Oops. Actually, that's not a bad idea. Right, so I've come like half prepared. I've set myself up with a couple of email accounts, Alice and Bob, to play with, and we'll be following the walkthrough. So, install Thunderbird already. You need to install Thunderbird Enigmail, which is an extension for Thunderbird, provides PGP support, and also GNU PG, which is what Enigmail actually uses for the PGP signing and encryption. So I've already set up these email accounts, as in like created them on the server and also configured the client for them. But so far I haven't configured them for PGP. So this is where I expect you guys would be at normally. So from here, with Enigmail installed, we put Enigmail key management, generate new key pair. Enigmail key management, you don't really need to see my other identities. Generate new key pair. This is where you get to put new passphrase. And I'm basically doing all the bad things here for the sake of trying to be a bit quick. What did we forget? Doesn't really like that, does it? Maybe it wants a passphrase. Let's put something in. I need to do the same thing for Bob. Oh, it's not going to let us. Okay, so generating keys is quite expensive in terms of randomness. Machines tend to be quite conservative about that, and we need to go off and do stuff when generating a key to give it a source of randomness.
What do you mean by that?
The key generation program will actually hang around and wait until something random happens.
Just moving the mouse to speed it up. With some of these programs that generate the random data or generating the key, moving the mouse is actually the source of random data.
Yeah.
In other words, instead of using a computer to, instead of using a set program to generate random numbers, it does it based on your actions? Is that what you're saying?
I actually don't know the detail for that, but you do have to do stuff, otherwise it's really slow.
Okay.
Yeah, so that's not right. So what it's doing there is, if you think about the way random number generators work on a computer, they're given a seed, and then you get a deterministic output from it. So what you're doing when you move the mouse, you're generating interrupts and events that are giving you a different seed. That's what that bar at the bottom is that it's building up. So you've got a random input to your randomization function.
I don't think those sorts of random numbers, I don't think are done by a seed. I think they generate, they look at random data.
Yeah, through dev urandom, but it's like, if you think of that, it's going to use the urandom input as the input to a randomization function later on.
If it uses urandom, it wouldn't run out of random numbers, but it does. It's probably using dev random.
But it takes a while for them to fill up, and that's what you wait for. That's why moving the mouse helps you.
Anyway, but beside the point, we've got our key
That's
pair.
okay, you pretty much answered the question. In other words, it uses the randomness of different people doing different events to have different catalysts for
You wanna
coming up
get
with
it
different
nice quick.
randomness for whatever.
But that only has to be done in the beginning to create the key.
Yeah,
After that, it's not something you have to do ever again.
this is done once. Okay, so Alice has,
You still need the exception.
yeah, but Enigmail takes care of that. Okay, so we're generating one for Bob as well, but we can go off and do other stuff here. So Alice has got hers.
Where entropy problems are a really big problem for any of the routers, for the first couple of minutes when you start up the machine, then the entropy will be relatively small. So the worst thing is things like the desktop routers that for when they're doing HTTPS sessions and all this sort of stuff, that they have no, often have no ability to save previous seed value. The first couple of minutes, or in the first 5-10 minutes, then the entropy will be very small. If you've got a user of a keyboard typing, it should be very easy.
Yeah. Okay, so we've generated our keys. That's basically it for the setup. To use it, actually,
Where do the keys go?
where the keys go, they get stored in the keyring. We, as a user, are largely unconcerned with that. Here's my notes. A few things, sort of haphazard. PGP encrypts the body of an email, not the subject line. Keep that in mind. So, yeah, just don't be giving stuff away in the subject line. It doesn't hide the that people are communicating, obviously. And it also doesn't hide the length of the message. I mean, a long message in plain text is going to end up the long message encrypted. It also can't prevent future attacks against the cryptographic functions that are actually protecting the messages anyway themselves.
It also doesn't hide who you're sending to key the key that it's for.
Yeah, that's...
You can script it, but 99.99%.
Yeah. Okay, so the option to attach the public key by default to emails in Enigmail is hidden by default. Thank you, I got a revocation certificate for that. So in Enigmail preferences, there's a button here. You need to display expert settings for that. And like every good UI design, it's somewhere else that the button pops up to actually configure it, which is here. Right. So attach my public key to messages, or you can use the publish into a key server approach.
So you can use a what approach?
So this is for distributing your key to whoever you want to communicate with. You can either attach them to the emails themselves and send them an email.
Oh, okay.
That way they can get your key. Or you can upload it to a key server and send the recipient a link to your key on the key server so they can download it.
Okay.
So in here, we'll attach the key to the messages. And we'll get Alice to send an email to Bob. See, it's attached by default. Actually haven't sent an email from here before. I'm not sure if it knows that password. Yeah. Okay, so Bob now has a message. What is it asking for? Bob's secret key. Did that encrypt by default?
We didn't have any content. How is it going to encrypt? That's how it decrypts. It decrypts to nothing. But why? Yeah, why did it? I don't know. Let's try again.
Is that the bottom of the message?
Yeah, it is, but it was. That should be readable without doing anything though. Okay, so yeah, there's your answer to what do they look like.
Okay.
But I don't know why it needed to decrypt that.
It seems to automatically be doing it because look, it's encrypted.
Oh, it's up there by default. I see. Yeah. Maybe there's a default setting in there too.
Yeah, there was a default setting.
Well, if you have the key for a recipient to automatically encrypt it, yeah, that makes sense.
Can you set it unencrypted?
Yeah, you just untick the
box.
that.
All right.
If you send a public key like that, how can you prevent the middleman there? So if I am middleman, I can just when I capture the message, I can just like send another public key
Yeah.
to Bob,
Yeah.
pretend to be Alex.
Yep.
So it's still not secure.
So offhand, what I can think of is you can send a message back and ask.
Pretty much everything relies on that first one being good.
Yeah, it's tofu, but
your first, you have to communicate that safely the first time, and then you're good going ahead.
Yeah.
If you hack the first time,
How to make sure it's
print it out, give it to the guy.
Out of band. So
read the fingerprint over the phone.
verification have in place the method of non-verification. Is in place. Typically, some sort of out-of-band transfer is one option. The Bill Zimmerman from the start wanting to brought in the web of trust. So when you upload it to a key server, well, when you go to someone like, well, we've got things coming up, that approach somebody that's highly connected, that then will go to one of the key signing parties, get the key signed, and upload the signatures. And if you've got the signature of somebody that's highly connected, then we'll be able to get a web of a friend of a friend. 7 degrees of Kevin Bacon.
Yeah, that is one way of using PGP. I was deliberately trying to avoid talking about that. It works, but it's, yeah.
How the band works then. want to keep it simple, then out of band, send them a snail mail.
Yeah, or telephone call or something like that.
Carry a pigeon.
Quite large.
Have you done him to read out the signature?
So we've already tested actually decrypting a message. Let's try signing. So and you can do one or both.
What advantage does having doing both have?
Sorry?
What advantage is if you do both? What does that have?
It just combines them. You're communicating with the other person privately, and they can tell that it didn't get tampered with, and that you sent it.
One gets you encryption message, so nobody can read the message.
Yeah.
And the other gets you the fact proof that you are who you say you are.
Yeah.
And they think yes, it has not been changed. So they're two separate things.
Okay. I thought you would have got that for free if it was encrypted.
No.
No. So when it's encrypted,
Because to sign it, to verify that it's you, you're signing with your key.
Yeah.
Anybody can read that signature or unencrypt that. Effectively, it's encryption, but anybody can unencrypt it with the public key and prove that you are the original person who sent it. Whereas the other way, you're signing it with their public key so as to encrypt it. So only they can unencrypt it. Okay. So
Yeah.
you go in two different directions.
yeah. So when Alice sends an encrypted email to Bob, Alice uses Bob's public key, and encrypts the email, then gives it to Bob. So anybody could have done that.
Right. Okay.
If Alice wants Bob to know that it came from her, she has to sign it.
Under a PGP.
Yeah. And, well, okay, yeah. Non-repudiation meaning Alice can't deny that she sent it. Okay, so Bob has a signed message, and we can check the signature. It's a good signature from Alice, saying that it hasn't been tampered with. I actually hadn't considered setting up test cases for bad stuff. What we could, I don't know. Anyone have any ideas for that, to tamper with one of the emails? See what happens. We could go into the Thunderbird profile and just edit it.
You'd have to set up a spoof.
Pretty sure it's just a server.
Where are the mails stored here? It's not asking, I can't read it. Okay. So that's basically it. The same works both ways. It's not really a lot to explain, and it's quite simple to use. Unfortunately, it's not encountered a terribly great deal in the wild. Not exactly sure why. But you have the option that you can say, attach it to all of my outgoing emails.
Yeah, the average user has not going to be able to, you know, I think my wife or in-laws or whatever, they have no clue how to put this because it's just too hard.
The other thing is you basically need a client, email client that actually supports it. Now, Thunderbird is one. It's a quite well-known one that supports it. I have no idea about any of the others. Some webmail clients do support it. For example, I use Squirrel Mail and it does. But then you have the problem of, okay, you were saying, should I store the key on the machine that I'm using to read my email? Well, if you're using PGP with webmail, you're going to go, okay, should I be storing the key on the server?
Which is remote.
And
You don't have control.
exactly, and you've lost.
Also, if you change computers, you have to make sure your new computer has the key.
Yes.
What happens if you send an email to someone who has an email client that doesn't have this stuff? Does it just show up as a bunch of garbage at the bottom of the email?
Yes, it shows up as a bunch of garbage for encrypted email, and if they don't have a key available or a client that supports decrypting it, then they just get to see a bunch of garbage. That's the desired outcome.
Yeah.
I was getting to that.
The context of this is you're not going to do it to send something to your in-laws or your family. You're going to use it for things that might have commercial or intellectual property value.
In an ideal world, I think everybody would use it, but the problem is it's not the default. And until it is the default, most people aren't going to do it.
Yeah.
And even when it is the default, it still requires some effort. For instance, you need to keep your key safe, because if your computer dies, you don't want to lose your identity.
Yes.
Or your emails.
Or your emails.
Yes.
What happens when the keyword expires? So after 1 year?
I haven't really dealt with that. I believe they can just be extended. The expiry.
Or does it just lock everything out?
Do you think keys have expiry?
The keys do have expiry.
That was one of the questions.
Set it?
You don't have to set it, no. You can say they don't expire. But if they do expire, you can, after the fact, extend their expiry as well.
So you can
Right, so there's
effectively
no
lock
point in having
everything
an
out.
expiry then.
No, the point in having an expiry is to tell other people that you've lost control of your key.
Anything is when you generate a key or so generate an expiry.
Sorry, revocation certificate. Sorry, yeah, I was confusing that.
Read it out.
I don't think revocation works too well because it requires someone to check if there was a revocation.
No, with the revocation certificates, you distribute them when you've lost control of the key.
To those that are important.
It looks like SSL certificate, that you need to generate another one and send it.
Okay, it's unrelated to SSL.
I send something to you, then after 3 months, that key expires, then you can't access the data anymore. So, is that what happens?
No, you can access data with expired keys.
Right.
It's a warning to people who are trying to send you stuff encrypted, saying that this key is out of date. You need to contact me for a new key.
Okay.
Yes?
So do you use like the encrypted email for every email you send then?
I use the signing for every email I send. What happened is when I was in uni, I don't know what exactly the problem was, but emails were being sent. They had the from field as my email address, and I didn't send them, and they were spam. And so from that point on, I decided to tell people, or to train anyone who receives an email from me to expect it to be signed. If it's not signed, it's not from me.
Yeah.
So, we're done.
Yeah, that's pretty much it.
Thanks very much, David.
Thank you.
So we're going to the pub after this. Everybody's welcome to join us. We're just going to Piedmont Bridge Hotel, which is just around the corner, really. Is anybody interested in hearing a part 2 of Tate's development course? Web app development? Raise your hands, please.